Hi guys, welcome to Learn Electronics Repair. I have an amplifier on my desk. This is an amplifier from an active speaker. 4 connections here, so I suspect this is a Bi-Amp or Bi-Amplifier module. Yeah, it says here out, I think. Looks like out. Out Avant. Okay, H plus H minus, L plus L minus. This will be for the woofer or low frequency speaker, horn or high frequency speaker. Okay, so there'll probably be 2 speakers in this cabinet, or at least 2. This is mains powered here directly, and I don't actually know what the problem is with this one. So I think the first thing we will do is just try and power this up with the current limiter, and let's see what it actually does. So we see the light bulb over there. I'll just switch this to limit. Okay. On. One flash and it goes off. So there's certainly nothing short in here. It's not drawing anything much in the way of power, which is fairly common for an amplifier of this type at least. Let's switch the limiter off and we'll have a look to see what happens with the LEDs, limit signaling on, okay? Well, they kind of flickered and went out. Okay. I think we need to connect some speakers to this. So I'm actually just going to connect my 2 full range speakers. Use one effect as a horn, one as a bass. At least we should be able to test this. The 8 ohm speaker, so they should be fine regardless of whether this is 4 or 8 ohms. I'm using these connectors, so these are speak-on connectors wired to 1 plus 1 minus, okay, and I've taken these out of old Molex connectors, the sort you get on an ATX power supply for connecting to the old ID hard drives and CD-ROMs and such like. I actually used my multimeter just to check, so H plus was there, H minus, and then L plus and L minus, so I know which way they go. Okay, let's connect some speakers and see what it does. So again, with the current limiter on, just in case something bad happens when the speakers are attached. Yeah, flashed and went out, that's fine, so we'll switch that off. Power up. Give it a bit of audio. Well, the horn speaker output is working but distorted, and the bass speaker output I have nothing, okay? And this is what we have. So one of the speakers attaches here. This is the high frequency speaker, okay. The other one attaches onto this PCB. This is the LF speaker. So we can take that off almost. There's another connection here. This actually goes to a little connector on there, and I'm pretty sure that's for an LED, basically, on the front of the speaker, power LED. So we can take that off. So this is quite an interesting design by the looks of it. We have mains power coming in, okay. You can see we have mains power going to this board here, okay, and also going to this board here. So this one is the one that had the horn speaker attached, that one had the bass speaker attached. So it seems like we have 2 amplifiers, each one with its own power supply, built on, transformer, big capacitors. Same under here, fuse, okay, transformer, big capacitors. So yeah, we have 2 separate amplifiers, each one with its own power supply. And then this board, from what I see, this is just the inputs and level control, mic line, boost, such like. It was actually set to mic rather than line, which is possibly why it was distorted on the horn, because I was actually connecting a line input, so that was actually wrong. Okay, so it's possible the tweeter amplifier actually works and the bass one doesn't. Now, because they have their own power supplies, it's possible there's some high voltage in these capacitors if this power supply isn't running. So we better check that. Safety first, guys, always remember. So 2.5 volts, practically nothing in that one. These ones on this power supply, well, firstly, this was working to some extent, so they probably discharged anyway. You end up with high voltage in the capacitors when the power supply itself isn't running, but they charge. So let's get this board off and have a closer look at what we have here. Okay, and now we have it. So the input board, the little mixer board, this says high and this says low. Okay, so high, brown, blue, red, that goes to here. So that's the input to this amplifier. The other one, low, that goes down here. So that's the input to this amplifier. It may not only be the audio input, it may be something from the volume control. I'm not totally sure why there are so many wires, but anyway, that's what they are. This is the mains coming in. And then we have this plug here, red, black, blue, which goes to here. So I'm confident enough to say that is the 15 volt supply for this. Okay, when I say 15, I mean plus and minus 15. It could be something else, plus and minus 9, but plus and minus 15 seems fairly common. This amplifier seems to be working with some distortion, and we may already have a good reason for that, which tells me this board was working. So the problem appears to be with this one. I noticed, although it was actually running, the on LED wasn't lighting up, and that could well be being controlled from this as well. So that only comes on if maybe this amplifier board is powered up. Wouldn't be surprised. And anyway, it could monitor the 15 volt output from that one, so it could tell. I would imagine that's what the other two wires are here for, whether this is powered up. Okay, so this is the board which is faulty. There may be others, but this one is definitely faulty, and it looks like, I don't know, doesn't look good, but it might just be bad soldering down there. That okay. What do we have? Well, power coming in. Okay, fuse, filter capacitor, filter inductor, bridge rectifier. Okay, large capacitors, switching transistors or MOSFETs, primary of this transformer to the secondary. There's another transformer there. Now that might be standby supply, or it may be driving these transistors if the controller is over on the low voltage side of the board. I don't see any opto isolators, so it seems fairly likely. Yeah, here's the big divide. So we have one transformer, capacitor there, C350. Where's the other one? Yeah, of course, here, the big one. So those are the two transformers. This chip SG something or other. SG3525AP. Okay, this is a pulse width modulator and possibly also PWM controller, but I don't actually see at the moment a PWM circuit on here. So that I don't think is actually driving these from this side. I'm pretty sure that that chip itself, which is on the high voltage side, is driving this power supply. Okay, so that suggests this one is a lower voltage or some sort of standby supply. On the low voltage or load side, IC03, two of these things, I'm pretty confident those are all-in-one audio to Class D amplifier chips. Those are probably rectifier diodes on the output of this transformer. Mentions a fuse, but I don't actually see it unless it's on the other side of the board. Unless that is a fuse, that brown thing down there. Okay. Yeah. Two large capacitors. What voltage are these? Can we see them? Not easily. This makes me think that underneath this heatsink are the MOSFETs, output MOSFETs. and we can see the output inductors there. What's this chip? Again, part of the audio processing, I would think. Okay, where to start? Well, split the problem into two. Does the power supply work? If the power supply works and gives us sensible voltages over here, then the problem is over here. Yeah, that's the theory. Let's see what we can find out with the multimeter. So, where do we start? The fuse. Fuse is gone. Fuse is blown. Okay, that suggests something's gone rather badly wrong. Let's have a look around these MOSFETs, which don't look very nice. In fact, actually, let's look across this capacitor or the output of the bridge rectifier, because that's where the supply rail comes from. In fact, there's two of them. Are there any shorts across these? There's no short there. And there's no short there, it was just charging up. So there's no shorts on those capacitors, but there could be a short across the pair. I'm not sure exactly which way round they are. Well, two ends are connected to each other anyway, because they're in series, I'm sure. Yeah, I don't think there's a short there. MOSFETs. Or are they transistors? Well, probably MOSFETs. B20MM50. B20NM50 sounds like a MOSFET number to me. Let's take a look. So one would assume gate or base. Probably MOSFET, so probably gate. Well, that reads very low. We'll just get a connection on this again. Okay. So very low, 0.0022, and it's telling me 2.9 ohms. This meter's nice like that. It gives you the resistance as well. Drain source also looks short. This one the same. I can measure from there. No, that reads open, and actually I was thinking it must read open, otherwise we would see a short across the large capacitors, yeah? And that reads higher resistance, but still quite low. Okay. I've had a look for a schematic, but I don't find one for this. Or a service manual. Maybe you know different. Okay, so for now we're on our own. This whole area looks like it's been overheating to me. But we need to unsolder these two before we can go any further. That's going to take quite a lot of heat to do that, so I think it's probably going to be better to unsolder these two capacitors, and maybe that one as well actually, and possibly even this one, so I can actually heat this area up better without causing anything particularly bad to happen. Okay, I've removed the capacitors. We can see here actually what's happened. These have obviously been running very hot before they failed. Other side of the board looks pretty much all right. This looks like it might be a damaged something or other. Let me just get a microscope. Yeah. Is that something stuck on it or something broken off it? Oh, just something on it. Okay, so yeah, that looks okay. Huh, these are definitely not looking okay, and it looks like this is a it was like a rubber sleeve or plasticky rubbery sleeve over the transformer, probably a bit of heat shrink, or yeah, like a big piece of heat shrink. And I think that's just warped somewhat with the heat. Yeah, that's what that seems to be. I'll leave that on there, I think. Okay, let's get these transistors or MOSFETs off here. Almost certainly MOSFETs. I'll add a bit of flux. I'm going to try adding some leaded solder as well. I might actually be able to remove these with 2 soldering irons. Let's give it a go. So heat the tab, get plenty of heat into that, and then we'll come across these 2. Let's see if we can get this off the board. Yes, look at that. How about that, eh? That was kinder than using hot air. Let's go with the other one. Plenty of heat into the tab, and then there we go. Same technique. Yes. I like that. I've cleaned the board up, solder braid, isopropyl alcohol, that looks fine. This is the other supply. I mentioned this being a standby supply, but I think probably actually this powers this chip and these chips, okay, this circuitry, and then the high voltage just goes to the power MOSFETs to drive the speaker, which will be under here. Now then, let's look at these transistors. Let's see. Well, I got a bleep and a low reading between, well, if it's a gate to emitter, also to there, it's 31 ohms. Most certainly that is short. This one, that's short from the gate. That's very short. So they are both faulty, and one is short to the gate, which is not a good thing, because that means we probably have some problems further back in the circuit, whatever was driving this. Let's see if this is something we can get. I've cleaned these up a little bit. So we have B20NM, I think that is 50FD, but this one is a little bit clearer. Yeah, this one's a little bit clearer, so B200NM50FD. It appears to be this one, STB20NM50FD, D2 pack, that is the correct package. Power MOSFET with fast diode. Okay, you can see it there. Yeah, strongly recommended for bridge topologies. That's exactly how it's being used in this power supply. 500 volts, 20 amp, and gate threshold voltage between 3 and 5 volts, typically 4. Okay, so we could test these if we get some. Let's see if they have them on AliExpress. And yes, so I can get a pack of 10 with the shipping and the cost. It's about €8, €9, something like that. Those MOSFETs have some circuitry underneath. You can see here, diode, transistors, similar thing here. And coming back this way in the direction of this chip. So this is the SG3525AF. I have these in stock. That is definitely driving those. I know this chip. We'll look at the datasheet in a minute. This one could be a voltage regulator. It looks like a voltage regulator. 7908. This could be the adjustable, but 79 would suggest a negative voltage regulator. It certainly looks like one. Has some resistors here. Not sure, because you would think one pin was ground. Oh yeah, that end is ground. Okay, we can try to find that one as well. So let's look for some data sheets. So yes, pulse width modulator, we can see. Possibly a typical circuit here. Yeah, here we have it. So this doesn't directly drive the MOSFETs from what I can see. We have outputs on pins 11 and 14. That explains why we can see some transistors and such like in between the MOSFETs and the chip. And this isn't exactly an application, it's a lab test fixture, okay? The other one, 790A, well, it said DJ44 on it, or DJ44A, but I couldn't find anything. 790A brings me to this one, Fairchild. It does have a Fairchild logo on it, so probably is this one. And that says it's a PNP low saturation transistor. So, PNP transistor. Yeah, we see a junction. We see a junction, so negative to the collector, should read high. Yeah, it's just climbing up there. Probably capacitor charging somewhere. Okay, so that's probably all right. And then this chip from 11 and 14. So it's a 16 pin package that is 14. Where does this go? Goes through the board. Let's see if it appears somewhere over here. Not directly. Goes to there and then through the board here. 3 holes in a row somewhere in this region. Appears to be somewhere I can't easily get to. Oh no, 3 holes in a row there. So that looks like it goes to these things. Does the other one come through there as well? So pin 12, that's here. Yeah, that also goes through that way. So I'd say that goes to these things. The MOSFETs are over there. Again, a bit of circuitry with some transistors, which may or may not be connected to those. I think we'll see if we can figure out what those are. Marked N4 and then P8T. Okay. Perhaps try taking a picture of that one. See if the AI knows what that is. But I will Google for N4 SMD code. I'm not sure if they go into here, but these look like transistors. Diode, another transistor. And then there's some more on the other side. Right. Possibly a dual MOSFET. Op amp I doubt, because we know it's connected to the output of the SG3525. It's asking what it's connected to. Okay, best guess N4. But it's saying with one more piece of context I can identify it accurately. Okay. There are 2 of these. They connect to SG3525. I'll put A. I don't think the A actually matters. Ports with modulation IC, one to pin 14, the other to pin 12. Circuit is an LLC bridge type SMPS. Oh, I'll also tell it, it can probably figure this out itself. These are output pins from SG3525. Okay, I mean the best with the AI, I think, is to give it, usually I ask a generic question just to see. For example, when I was having problems with my van with the clutch not working properly, I gave it the symptoms without telling it the vehicle. It gave me some suggestions, then I told it the exact vehicle, and it said it's this option, and it's a common well-known fault on these vans. Okay, so we've done a similar thing. I've asked it to identify the chip, and now it's not sure, but it has some options. I'm telling it the context it's used in. Let's see what happens. Okay, given there's 2, and they tied to that chip. LLC bridge SMPS, most likely rolls, totem pole, output drivers. So a dual transistor, NPN plus PNP, yeah, or dual NPN with level shifting, okay. Used to increase the drive current from the SG3525. So it obviously knows what these are, really. It's telling me how I can confirm by following the traces, okay. It's telling me how to test them with a multimeter. It's saying it can be more precise if I show a clear wide photo, but it's double-sided. It's a bit difficult to do that. I do see a small series resistor. Yeah, I think we do. Very likely that's what they are. So dual transistors, basically. So it could go further than that, but I don't think I need to right now, and I'll explain why. If these are dual transistors, totem pole type thing, those are probably some series resistors in that. We know they definitely connect to the outputs on the IC, okay. And then we have some circuitry here, and we also have some additional circuitry under the MOSFETs. Let's have a look around to see if we can identify what these are, transistors, and really just checking for any short circuits we might find, okay. So This one doesn't really read anything. Let's go the opposite way. Is the PNP transistor? That's a junction. That's a junction. Looks like a PNP. Put the negative on the collector. And yeah, I get high reading. That's fine. What about this one? This is an NPN. Hey, good guess. Complement NPN. Positive for the collector. Climbing up. Diode. That way. Yeah, looks like a diode. And one down here a bit hard to get at, but looks like an NPN to me. Positive to the collector. Yeah, highish. Okay, so I think that's the oscillator that drives this, and it looks okay. This I'm not totally sure where that is involved, but however, we have these circuits, and I think we can test these pretty well. So, diode. Yes, a fast diode of some sort. Reads about 0.4, okay. Diode. Reads 0.58. Open that way. And that should be the same as this one, I think. I think they're identical circuits. Yeah, 0.58. Open. Transistor. Well, that reads 0.59, but nothing to there. That's the same, okay? So these are probably PNP. There must be a base emitter resistor, which is what we're seeing the other way around. They're both identical, and this way round we actually had, well, the meter saying 777 ohms, not particularly a standard value, but hey, that's what we have. But they're the same, okay? Diode, 0.60, 0.58, 0.60, 0.58. So again, the same, fine. This little circuit looks like a PNP again. Climbs up. Is this the NPN? Yeah. Reads open, fine. Looks okay. Looks the same. Oh, that's slightly higher reading. That reads more like a Zener diode, 0.70. Okay. So all that looks all right as well. And we're almost back to this chip now. And it all looks okay. So even the stuff directly under those MOSFETs looks okay. And I expect that the MOSFETs do not connect directly to those little chips. Okay, so we can check this quite easily. No, they don't go directly there. Okay, there's obviously some other circuitry around here, which may or may not be connected to this. This is probably an oscillator circuit for that power supply, but we can just check around there in case it is in some way related. I don't see any other ICs, so that probably is an oscillator. And we have a little bit of discoloration. This is gunge or something, actually. I'm not sure what that is. Yeah. Probably flux. I think probably all the rest of this is okay. Just the MOSFETs died. Yeah. Something else would have blown in between to damage these, I think. Okay, I'm quite happy with that. Now then, why did the MOSFETs fail? Well, most probable is either this thing was just being overdriven and they were just working too hard. By the way they failed, running hot and then giving up by the looks of it, I suspect that is the case. If there was a sudden short, they would have just blown, but they wouldn't have heated up like that. Do you guys agree with that? We can have a look. So these are the output diodes on the secondary of the transformer. Let's see how they look. So it's probably just a dual diode package in actual fact. These will probably read short because they'll be either ends of a winding. In fact, they don't. That's charging a capacitor, not a diode. Let's look at this one. Maybe they're not what I think they are. No, in fact they say TR, transistor, yeah. So those are not the rectifier diodes. Look like MOSFETs. This could have synchronous rectification. Let's look on the other side. Yeah, there's two more. Okay. The same. What do they look like? Well, they ain't short, but you can't really test them in circuit, particularly being MOSFETs, okay? Yeah, these connect together. Well, they don't connect directly together. There's like the secondary of the transformer, probably a center tap there, maybe. And this end is in parallel. Okay, let me just describe to you synchronous rectification, because you might not be familiar with this, and it's one you should know about. There's quite a few articles about synchronous rectification on the internet. Here's one of them. So this looks like a bridge rectifier, yeah, but it has MOSFETs in parallel with the diodes, okay, that you would normally have, just the diodes. The whole point of this is that the diode drops about 0.5 of a volt, okay. A Schottky diode is less, maybe 0.15 of a volt, 0.2, something like that. But the MOSFET across the drain source, when it's on, can have an RDS on down into the milliohms. So effectively you lose less voltage in the rectifier, and by that you actually generate less heat. It's more efficient. So that's one type. Here's another, basically the same sort of thing. So you can look these up. These effectively are just using diodes to switch the MOSFETs on when the diode conducts. But there's a different type of synchronous rectifier that actually uses an IC, such as these type, TEA, whatever, and there's a few other ones around as well. So this is probably where the synchronous comes more into it. So these type of chips, normally, they are the pulse width modulator for the switching transistors that's driving the primary of the transformer, and they also switch the MOSFETs, which are the rectifiers, on the secondary, and they synchronize the two so that when you get the highest current flowing through the primary of the transformer in either direction, they switch the appropriate diodes on in the bridge rectifier, effectively on the other side, okay? So that's what synchronous rectification is. And I don't see any controller IC on this board, unless I'm just missing it. Other side, what do we have? Yeah, I'm sure these are the amplifier, Class D Amplifier chips. So I think this is just effectively like the one controlled by diodes. I haven't really looked at it. Or the components I'm looking for are just not easily visible. What is easily visible is this fuse, okay? Now, if something's gone wrong on here, which is blowing those transistors up, I think we can say it's blowing the fuse as well, because this is only a 630 milliamp fuse, which seems a bit low, to be quite honest with the amplifier. I've got a feeling that isn't in the circuit that powers the amplifiers, but we need to check it anyway. And it looks like it's here, F300. And that reads okay. Another good place to check for shorts would be across the capacitors here. Okay, so this is effectively the output for the transformer. So you'd assume that this is voltage rails, maybe a plus and minus, quite likely. Let's have a look. Well, there's no short circuit. Two pins will connect to each other. Those, and this is across the whole pair, and there's no short. So that doesn't seem to be the case either. The two chips, so these will be driving the output MOSFETs, which are under here. The reason there's two, I'm confident enough, this is a pair of amplifiers running in bridge mode. That's what you would expect really for a Class D bass or sub amplifier. Okay, yeah, these are connected to each other, and that goes to the negative end of this capacitor. Positive of this one will go to the negative of that one, and then that point there must go to the other MOSFETs, which are on the other side of the board, I would think. So here, yes, so that goes to here, which is the other MOSFETs. So we have a plus and minus volt supply here, I'm pretty confident. The center point of the capacitors then would go to here, which is the center of the winding. Okay, so we have a plus and minus volt supply here of some description or other, and that's ground. So I don't immediately see any problem over there. Right, this could get interesting. If we put these capacitors back in, leave the MOSFETs off, because I don't have them, and power this up, this supply should run, and we'll get power to this chip and these chips and all the associated circuitry here. Now obviously this supply is not going to be running, but if I use my bench supply to put a plus and minus across the capacitors, dual supply, the center point ground, which is there, or the junction of the capacitors, I can power that up as well. And this amplifier, if it's good, should run, and we should be able to play music or sound through it. And if we can, then I think we're confident enough to say all this works and we just need to replace those. What do you guys think? Well, if we're going to do that, we need to know what voltage is on the supply, and the best way to figure that out is to take at least one of these capacitors out and see what the rating is, and then it's going to be less than that. Yeah. Okay guys, so we'll leave that one there for now. This was getting really long, so I've split it into two videos. I've done both videos, so they're both completed. There is a resolution to all of this, and it goes quite in depth. So I'll publish the next one tomorrow, and then it can carry on. But in the meantime, feel free to chat about what we've done so far. Okay, hope you enjoyed that, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.